Hello everyone, myself Jitendra. Today we are going to start a new topic, reverse humor problems. Basically, this is very good application of relative motions. In reverse swimming problem, basically there will be one objects. It may be swimmer, it may be boat, something. So in this chapter, first we will derive minimum time and further we will derive how we can reduce the drift. So let us start. So basically there will be three parameters, vr, vsr or vs. Vr, this is velocity of river with respect to ground, means velocity of river seen by the observer that is sitting on the ground. And vsr, velocity of swimmer with respect to river, not with respect to ground, this is with respect to river. And vs, that is velocity of swimmer with respect to ground. We can write like this: velocity of swimmer with respect to ground. Let us understand with the examples, like this river flowing with velocity vr, that is 10 meter per second. And one swimmer swimming with respect to river in direction of river, that is vsr, that will be 5 meter per second. So how much velocity that a observable seen sitting on the bank of the river? We can use formula of relative motion, like velocity of swimmer with respect to river will be velocity of swimmer with respect to ground, velocity of river with respect to ground. So velocity of swimmer with respect to ground will be, so basically velocity plus, so that is 5, and that will be 10, so that will be 15 meter per second. So that is large velocity. So now we are going to uh, resolve the components of velocity in x and y directions. So in next slides, we can assume this direction is x and this is perpendicular direction will be y. This, so this is basically angle theta made by the swimmer with respect to this perpendicular direction. So uh, this is vr, velocity of river, and our river is going to in x directions, and swimmer is moving this directions. So the resultant velocity of swimmer will be, we can suppose, will be in this direction. So this is drip d. Basically drip d is the distance traveled by the swimmer in x directions. So here we can see that uh, uh, this is angle made by theta vsr. uh, we can resolve in two, well, two components. So perpendicular directions, it will be vsr cos theta, and this will be vsr sin theta. This is velocity of river. So here we can see that there is one velocity in perpendicular directions, and two velocity in horizontal direction. So this vsr cos theta, this component is responsible for crossing the river, and these components will be responsible for drift. So first I can write that drift. What is drift? So drift will be uh, distance traveled by swimmer in x directions. We can say that x direction and horizontal direction. So VSR cos theta will be responsible for crossing the river. So let us take width of the river is W. So total time will be distance divided by speed. So distance is W, and this velocity will be VSR cos theta. So this is time taken by the swimmer to cross the river, and in x direction we can see that we can write Vx. So the net velocity will be Vr minus VSR sin theta. So this is basically responsible for drift. Drift is the distance traveled by the swimmer in x direction. So d will be velocity, so, sorry, speed divided by time. Sorry, speed multiply time. So speed will be Vr minus VSR sin theta multiply time. Time is W divided by VSR cos theta. So basically in exams most of questions asking on like minimum time, how can we reduce the drift. So in next slides we will see the this problem like condition to cross in minimum time. So what will be cross uh, minimum time. So formula for minimum time will be W divided by VSR cos theta. So time will be maximum when denominator will be time will be minimum when denominator will be this will be maximum. Basically width of river is fixed, and VSR will be fixed, so we can change only theta. So cos theta, maximum value of cos theta will be 1. So put this value, and here theta will be 0 degree. Means swimmer have to swim perpendicular to the direction of river. So this will be a good function for minimum time. So formula for minimum time will be T will be omega divided by, sorry, W divided by VSR, and we can write like this, like this is VR, this is VSR, and VS. So we can put VSR in this direction, so we can apply triangle law of vector addition. So basically this is VSR, and this we can write like this. So VSR, we can shift a vector in parallel direction, so there will be no effective. So here applying triangle rule, so Vs will be Vr vector plus Vsr vector, and we can use simple Pythagoras theorem that what will be velocity of shimmer will be root of Vr square plus Vsr. So this is very important results we can use further. So we can take we can find out direction, so this will be phi. So we have learned only already in vector addition, so tan phi will be here Vsr divided by Vr. Tan theta will be this perpendicular divided by base, so perpendicular is Vsr and this will be Vr. So next we will move to next slide. So here second is condition for drift to be 0. So for drift to be 0, we can see that formula for drift we have derived in last expression. So Vr minus Vr sine theta and multiply time. So we can see that if Vr equal to Vr sine theta, then drift will be 0. So means if we write here like Vr in component form, Vr cos theta Vsr sine theta, and this is Vr. So in horizontal direction there should be no net velocity in horizontal direction. So if there is no direction velocity in horizontal direction, so there will be no drift. So this is condition for drift to be 0. And one important results will be like that here sine theta will be v r divided by Vsr, and we know that sine theta will be equal and less than 1. So Vr divided by Vsr 1 and Vr, so means there is condition for here I have some missed Vsr. So there is condition for drift to be 0. So we can produce some important results like we can write this is like Vr and Vsr, this is, and sorry, this is not this is Vsr. This is Vsr, and this will be velocity of shimmer. So this is velocity of shimmer. So this making theta. So here we can find out that Vs is using Pythagoras theorem. it will be is and vs, sorry, uh, so I made some mistakes here. Vs square equal to vs square minus vr, so vs equal to, so basically this is very important results for drift. So here, and this is very important for drift to be zero. If it happens opposite, so there will be never drift will be zero. So in next part we are going to solve one numerical problems, uh, like a river 400-meter wide is flowing at a rate of 2 meter per second. A boat is sailing to a velocity of 10 meter per second with respect to the water in a direction perpendicular to the first. We will write all the things that is given in the questions. In questions there is given width of river will be 400 meter and flowing at a, this is velocity of river, basically given by 2 meter per second, and velocity of boat with respect to water, that is given by, we always write like this, v, there is boats, we can like vbr equal to 10 meter per second. So first part, find the time taken by the boat to reach the opposite bank. So uh, we have to calculate minimum time. So so here we can use formula for minimum time. So time t will be w divided by v br. Basically we derived in last second last slides. So width of river will be 4 and vbr will be 10. So time will be 40 second. It is meter, it is meter per second, so time will be 40 second. It is not in good. 40 second. And in v part, how far from the point directly opposite to the starting point does, so we have to find the drift, how much drift. So in drift formula we have seen that there will be only horizontal river velocity that will try to move boat in horizontal direction. So drift will be vr divided by time, sorry, multiply by time. So vr is given by 2 and time will be 40 second in meter per second, this is in second, so time will be, sorry, drift will be 18 meter. So this is one numerical problem, and in next slide we are going to solve some other problems. This is very good problems. First we have to write the given things in the questions. So a man wishes to cross a river in a boat. If he crosses the river in minimum time, he takes 10 minutes with a drift of 120 meter. If he crosses the river taking shortest route, he takes 12.5 minutes. Find the velocity of boat with respect to the water in minute meter per minute. So first we will write all thing that is given in question. So here there is two conditions. First, if he crosses the river in minimum time, so he takes 10 minutes. So what is formula for minimum time? So T equal to W divided by VSR. Means VSR, we can write VBR here. VBR. So width of river is not give not given in question. So basically in minimum time we have given drift. So we can use formula for drift. For minimum time drift dr will be vr divided by time taken. So drift is given by 120 meter, and velocity of river is we have to find out. So and time is taken by 10 minute. This is in meter per second, sorry, in meter. So and this is in minute. So velocity of river will be 120 divided by 10. So this is 12 meter per minute. And in second conditions, that is given as if he crosses the river taking shortest route means he have to travel in exactly perpendicular direction, so drift should be at 0. So he take 12.5 minutes. Find the velocity of boat with respect to water. So basically we can find out the one equation from here, like time taken will be from minimum distance, w divided by vbr, and time taken will be 10, and w we have to find out. So vbr. So here w will be 10 vbr. This is first equation. From second conditions, so we have to find shortest route. So we have we know that velocity width of river will be vb divide multiply by time. Basically vb is the velocity of boat as seen by ground and divided multiply by time. So for vb we have derived expressions in previous slides like this. We are going to use this. So width of river will be I think it will be right. So let me check. We so put the value from equation 1. So that tell you 10 VBR. So on squaring both side, that this is y, sorry, time, this is time, and time is 12.5 का 12.5 whole square will be 100. That we have to solve this, and we will, after solving, we will get VBR will be 20 minute meter per minute. Basically this will take much time, so I write directly. So this is all about the reverse Riemann problems, and next we will learn about um, 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 rain umbrella problems. So today, thank you.